Hey guys, welcome back to my YouTube channel. So in this last lecture, we have discussed about the difference in the doping levels and those things is, and we have started with our n-type uniformly doped. So in this instinct, what will happen is that every state will remain as it is. So that we discussed detailedly, right? So the EC, EV and the Fermi level formed by the donor atom, which will also be same. So which is without external supply and with the uniform doping. So let's get into next thing, like when there is an external voltage is applied. So if you guys see, the voltage is applied from this direction, so the electric field will be pointing to this way. So the electric field will be from positive to negative, so this way it will go. So here there will be electric field that will come into picture. Because of this electric field in this direction, the holes will be electrons will be moving in this direction. So electrons will be moving in this direction. So this is electrons. So some minority holes will be there, right? So that will move in some that direction. So that is similar to the electric field, or that is opposite to that of electron movement. Okay. So that the net current will flow in this direction. So this is our net current. Here the net current will flow because it is an n-type with external supply. So the current will be flowing in this direction, and the holes will go in the direction. This is holes. So let's plot the diagram. So as there is an external supply, the electrons is moving in this direction. So if electrons is moving in this direction, then the energy level will shift to this direction. So the energy band will be shifting slightly to the upward. From the direction which is flowing, it will go to upward. So let me draw it. So if we think it, the same state, it will be in that direction, but the EC will be shifted in this way. Okay. So EV, that will also be shifting in this direction. So the EFN, that will also be in this direction. Okay. So there is an exact drift. The complete everything will be similar, uniformly drifted to the same angle. Everything will be in the same angle. So this is our reference EFI. Okay. Here you see this is EV, this is EC, this is EFN, and this is EFI, intrinsic energy level. Okay. So as you guys know, the electric field in this direction. So that's why there is shifting to this one. So the energy state which is in direction which is shifting to that, the inclined in this direction. So we can clearly state that the difference in EFN, the rate of change of EFN across the distance, which is not equal to 0. So because of this, there will be a current flow that will also be not equal to 0. So that's we are getting the current flow here. Okay. So this is some kind of references that we get. So let's see how the changes will be here. So we clearly seeing that some kind of rate of change, right? So this distance, this is the rate of change that is got. So that is we are getting. So let's get into understanding how much this will change and depending on how much. So P, the potential energy, is nothing but EC minus E reference. So which is the reference value to that of current value which is got changed. So now let's find out how much the drift or how much the change in the energy level. So we know that potential energy which can be written as minus QV. So we can substitute that in the first reference formula, EC minus E reference. Okay. So if we substitute it, then EQ, the V can be written as dV by dx because which is changing to that of distance, right? So if we are making differentiation, we are differentiating the entire equation, and then E R reference to that of dx. So this will be going to 0 because reference value will be something stable or something linear that is not changing. So we will be getting into this one. So if we divide by Q, then dV by dx, the voltage applied to the along the distance, which will be directly proportional to the energy level change. So we are clearly coming into observation that the how much there is a change in voltage applied to that device, that much change in the voltage, that much change in the energy level we can observe. So this change we are seeing here, right? So this will be similar to that of how much voltage that we are applying here, V, across the distance. So they are clearly giving a one of the wonderful statement that the minus dV by dx, which is the change in voltage, so which will be directly proportional to dEc divided by dx. So we can see the negative sign, which indicating that the electric field change will be in the opposite direction to that of the energy level change. If the energy level change is in this direction, then electric field, the voltage change will be in this direction. That will be opposite to that. So that we will come into picture in next observation. So for now, so what we can state is that we are clearly seeing a slope of difference, which is because this is clearly because of the voltage that is applied. So the electric field, which will be directly proportional to dV divided by dx. So this is a direct formula we already know. It can also be now written as 1 by q dc divided by dx. Okay. So this is not only for conduction band, it will be also for the valence band. So it will be d ev divided by dx. Okay. So which is also for the intrinsic Fermi level. So 1 divided by d fi divided by dx. Okay, the slope of the conduction band, valence band, and intrinsic Fermi level represent electric field. Right, the electric field is directly positive slope direction of conduction band. So here I am writing the definition or significance behind the above expression. The electric field is directed in positive slope. In this case, it is directed to positive case. So in this case, it is directed to positive slope because of the voltage that we are applied in the direction to that. So positive slope direction of conduction band, valence band, and intrinsic energy level. Okay. Intrinsic Fermi level. If we reverse or apply some kind of different potential, then we can clearly say that we can clearly see some kind of other difference. So let's get into that point. So here we can see the same diagram, same n type, but here if you see, let's reverse the polarity. So let's take here it is positive and here it is negative. Okay, so this is happening like this way. Then what will happen is that the electric field will be from this direction. This will go in this direction. Okay, so just we are reversing the polarity. Okay, so electric field will be in this direction. Then what will happen is that the electric energy level will be drifting in this direction. Okay, we could clearly say it will be drifted to this direction. So here is EC, here it is EV, and then here we could clearly see the Fermi level formed by the donor atoms, and this is intrinsic energy level. Okay, I hope you guys able to understand it, right? So the net change is directly proportional on the electric field. So electric field is happening in this direction, then that is directed to this direction. I hope it is understood. So the starting position will be down and the electric field increasing in this direction. So energy level will also be shifted to this direction. As you can see, it is shifting to this direction, electric field. So this is EC, this is EV, and here it is EFI, and this is EFN. Okay, I hope it is understood. The current is directed in positive slope to the direction. So here we see the voltage will be in the opposite direction to that of electric field, right? So I am plotting that also for you guys to understand it. Okay, so this is a slope of direction curve. So this is x and this is v of x. So v of x will be exactly opposite to that of this. So this is directly into this direction, right? So that will be directly into this direction. So that will be quite opposite to that of that. Okay, I am taking this one. So there will be continuous change in the direction. So as you see, positive, negative. So even you can keep a note of like this, positive, negative. So this is positive, this is negative. So here you can see this will be greater, this will be negative. Here you see this is greater. So here it will be positive, here it will be negative. So you see this is positive, this is negative. So here it is in upper level, here it is in lower level. Like that way you can remember, but that is not an exact term. So for your understanding, I am stating this one. So I hope you guys able to understand how the how the energy band is shifting based on the input voltage. So we are clearly see that this amount of change, the change in the thing, the electric field, which will be directly proportional to dV by dx, and this the voltage change will be directly proportional to 1 by q dV divided by dx. So I hope this is very important observation. that this is very much needed, because whenever there is a current movement, there is a band, the energy level movement is happening across the distance x to that of electric field. So I hope this is very much good, and I guess you got the point. If you guys have any doubt, please ping in the comment section so that I will clear you the doubt. So from next lecture, we will be going through non-uniform doping. So that will even give you more understanding of how the non-uniform n-type and non-uniform p-types are working. So I hope this lecture we can end it here. So like, share and subscribe our channel. Stay tuned for the next lectures. Thank you guys.